Password.
Sainath Baba. Correct అవుతుంది చూడు. Hello.
Yeah, hi, sir.
Yeah, hi. Good afternoon.
Good afternoon.
So in previous class, we studied about the friction and different types of problems on frictions, right? When we have to use the static
Right.
friction, when we have to use the kinetic friction and all.
Mm.
So the main theme of this question is just we have to find what is the acceleration of the bodies, or what are the tensions or the forces which is applied on the string or a different type of bodies. That's it, right? So now, what is this Newton's first law states?
So what?
What does this Newton's first law states?
So your voice is breaking. So can you just give me 1 minute? I think it's my internet connection. Just 1 second.
Yeah.
So can you just say something now?
Yeah. What does Newton's first
Yeah,
law
okay,
states?
so now it's fine. So first law is that an object tends to stay in motion and or it like rest unless an external force is like applied on it.
Okay, that's a normal statement from. Then how we are using that statement in the problematic solutions?
F is equal to ma.
That F equals to ma, right?
Right.
So this is the net force acting on the body, right? Which is equals to mass of the body into acceleration. This is F equal to ma. So here, what does this Newton's first law states that the body is at motion until and unless or stays at rest until and unless an external force is applied to it, right? Means
Right.
F net is 0. Then the acceleration of the body is 0. Or the net acceleration, correct?
Yeah.
So means when the acceleration is 0 means the velocity is constant, correct?
Constant. Yeah.
By using this first law, we find out what is the acceleration, what is the forces required for a body to be in equilibrium and all we studied. Now what is this Newton's second law states?
That force is equal to the rate of change of momentum to the
Force equal to rate of change of momentum. So this F equals to ma came from this Newton's second law. Okay.
Okay.
From second law itself, we got this F equal to ma because this P equals to mv. On differentiating, we got by keeping the m constant, delta v by delta t is nothing but acceleration. So we got that F equals to ma. If the mass is constant. If the mass is not constant, then we will use this differentiation rule for the mass also. Now, what is this Newton's third law states?
Every action has an equal and opposite reaction.
So for every action, there is equal and opposite reaction. Okay. Now let us suppose there is a body over here, and there is a mass m. So there are two forces. First is this mg, downwards, gravitational force. And the normal force, which is acting upwards. Now, what is action and reaction forces over here?
So action is mg, right?
So we're talking about action is mg.
And reaction is normal force.
Action is mg, reaction is the normal force. So, no. The main 3 points of the Newton's third law. Okay. So first one is this action reaction, right? This action and reaction acts on different bodies. First part. It is not acting on only one single body. It is acting on different bodies. Okay. Now the second rule is this action reaction pair. Because for every action, this action reaction pair are of same nature. Okay. Same nature in the sense here mg is the gravitational force.
Right.
N is the normal force. Both are different. They are not action reaction pairs.
Yeah.
N and mg, they are not action reaction pairs. Okay.
Okay.
And the third one, obviously, we know that forces always exist in pair. That's why you're getting this action reaction pair and all. So forces always exists in pair, right?
Right.
Now let's see this. What is the action and what is the reaction on this? So by going these three rules of this third law, what we can tell is, let us suppose the body of m mass over here, right? That mg is nothing but the force due to the gravitation, means the force of gravitation, right?
Right.
Mg means the force on the body due to the earth, right? That is mg. So for this mg, this body mg, it also attracts itself the earth. This is called the force on the earth due to the body. Okay.
Okay.
Actually means when there is a body, one force is, we know that the earth is pulling downwards the body. With the same magnitude, the body also attracts the earth towards itself. This is called action. For this action, this is the reaction. Okay.
Okay.
Now for understanding this is the normal force. This is the surface. Now we know that normal force is the force applied on the body due to the surface, right?
Right.
This is the normal force we are taking. Now the same magnitude, this body also applies on the floor, on the surface, means force on the surface due to the body. It also called as a normal reaction. Okay. This N, it is on the body. This N is on the surface. Okay. So this is the first rule. Action and reaction acts on different bodies. So for this action, this is the reaction. So first action, it is acting on the body. the reaction is acting on the surface. Okay.
Okay.
This is the action reaction pairs. N and Mg, they are not action reaction pairs. We are just equating them because the body is in equilibrium in the vertical direction. That's what we are equating. That's it. And normal force and Mg, they are not action reaction pairs. Okay.
Okay. Okay.
Then why this is useful is because let's suppose this is a rope string and there is a monkey, okay, which is climbing the rope. Okay.
Okay.
Now this monkey is exerting some force on the rope, right, towards downwards.
Right.
For this is the action. For this action, the rope applies monkey of a force upwards. That's why the monkey is moving upwards. Okay.
Okay.
For this action, the monkey applying a force on the rope, it is applying an reaction such that the monkey is moving upwards. So means what we can say now, the force which is going upwards is nothing but, let us suppose this is F. With the same force F, it goes up, right?
Yes, sir.
Let us suppose the force, that is nothing but the tension of a string. So it is nothing but the T. Okay.
Okay.
So the action is towards downwards. This is the action force. For this action, the reaction is towards upwards, which is responsible for the monkey to move upwards. Okay. No. Let us suppose this one. What is the tension in the string? Okay. In this question, what is the tension in the string when a monkey of mass 20 kg is climbing upwards with an acceleration of 3 meters per second square? What is the tension in the string?
So 60 Newton.
16 Newton. Okay. How?
Because using acceleration and mass, we can calculate force, and force is equal to the tension, right?
So you calculate that F equals to ma, like this one, right?
Right. Yeah.
This is the net force, right? It is not just the force, it is the net force. Correct?
Oh,
For
okay.
telling, then
Yeah.
you have to take all the forces which is acting on this monkey. So first force, we know there is the gravitational force acting downwards, that is 20 G, right?
Right.
Now what is the other force acting on this monkey?
So 1 second. Yeah. There's 20 G acting downwards, and then there's tension, which we have to find.
Okay, tension.
That's it.
Okay, in which
Yeah.
direction?
Upwards.
Tension upwards, because the monkey is pulling it downwards. So the tension
Upwards.
will
Yeah.
be up. So this is the T.
Upward.
Now they are the only two forces in this body. So just we can calculate it. So T, because it is moving upwards, so we are considering that T is greater. T minus 20 G, that is 200, should be equals to the mass of the body, 20 into 3. Correct?
Correct.
Then we have the tension as 260 Newton, not 60 Newton.
Okay.
Okay?
Okay.
No. I think you know about this weighing scale, right? what this weighing scale, how this weighing scale measures, or what it measures in general. Weighing scale measures the weight of a body, right? Yes. So now in general we know that weight is nothing but I'll keep it over here. One second. So in general we think that the weighing scale measures that weight, that is as mg. But the weighing scale doesn't measure this mg. Remember, weighing scale works on principle of this normal force. Okay, how much ever the normal force is, it shows in the weighing scale. That's it. But in maximum cases, we are considering we will get that normal force as mg. But it depends upon the situations. Let's see how. So the one thing you have to know is weighing scale measures this normal force.
Okay.
Now let us suppose you are in a lift.
So we're discussing laws of motion right now, right?
Yeah, in that laws of motion, then they just for 2-3 problems. Next we have these constraint motions. That is the end of this
Okay.
laws of motion chapter. So here the person of mass m. Let us suppose we have 50 kg, the mass of the person. Now he is weighing, he's seeing the weighing scale. If the lift is moving upwards with an acceleration of 2 meters per second, then what is the reading on the weighing scale? Will it be same as 500 Newton or anything others?
So can you just repeat? I couldn't hear you.
Yeah. The mass is 6 kg. Okay. The mass of a person is 6 kg and he is in the lift and he is
Okay.
reading or he's taking the readings of the weighing scale. Okay. Now, if
Okay.
the lift is at rest,
Okay.
then what will be the weight of the person? And if the lift is at, it is moving upwards
Right.
with acceleration of 2 meters per second, then what is the reading of the weighing scale? And if lift,
So when it's at okay.
when the lift moving downwards with same acceleration as 2 meters per second square, what is the reading in the weighing scale?
So if it's at rest, it'll be 6 kgs only, right?
Okay, this is the mass. That's very good.
Oh,
That
sorry.
is
Yeah.
60.
Yeah.
So that is 60.
Yeah, 60.
That is 60. Okay.
And
If it is at rest,
yeah.
okay. And if it is moving upwards,
Uh, it'll be 120. Will it be
why
120?
120?
No, it won't be 120. I don't know, sir, but I just know like it'll be more than it'll be lesser
It will
than when
be
it's moving downwards.
When it moves downwards, the weight is less. When it moves upwards, the weight is more, right? Okay. It is here also using the same concept as the
So won't the weight be more?
when. Let's calculate and see
Yeah,
which
yeah,
comes
right.
more or less. Okay.
Okay.
Now, when it is moving upwards with an acceleration of 2 meters per second square, tell me the forces. Forces is nothing but forces acting on this person.
Uh, force due to gravity
Okay, person
and
force due to gravity downwards. 60.
yeah,
Okay.
and then normal force.
Okay, normal force will be there.
Uh, that's it, right?
These two, right?
Yeah,
So we have that F net equals to MA, correct?
right.
So means it is moving upward. So N minus 60, that is 60, is equals to mass of the body into acceleration. They give us 2, right?
So why we subtracting it? What are we
Both are in
subtracting?
opposite
Oh, the
direction.
weight of the thing. Yeah, yeah.
So
N.
N minus 6G. Okay, I have to
Hmm.
direct 60. N minus 60
Hmm.
should be equals to the net force equals to mass of the body into acceleration,
Right.
right? So
Yeah.
we get this as 12 plus 60 as 72 kgs. That is 72 Newton itself, right?
Right.
Now, when the body is moving downwards, same this normal force will be upwards itself, and
Hmm.
mg is for this person. Normal force is upwards, mg that is 60, but acceleration is towards downwards. So what we will do, 60 minus n should be equals to mass of the body into acceleration, right?
Yes, sir.
Hmm? Now, that implies that normal force we get as 60 minus 12. That is 48 Newton. That is 48 kg. Understood
Yeah,
this
sir.
one?
Yeah.
So always you have to take the acceleration of the total system. Okay.
Okay. Okay.
Now, we have this conservation of momentum that we will study in this rotation motion itself. It's just a simple topic. Otherwise, just so what this conservation of momentum tells. So conservation of momentum. So what is the formula for momentum? P equals to
Mass into velocity, mv.
mass into velocity mv. So what is conservation of momentum tells is whatever the momentum of the system, we are not talking of the bodies, means
Okay.
we are talking about the total system. There may be any number of bodies. We are considering the total number of bodies as one whole system. In that system,
Okay.
the momentum is always conserved. Conserved means initial momentum of the system is equals to final
Final moment.
momentum of the system. Okay. This is a
Okay.
conservation means there is no loss, no gain. Whatever it is in the initial is the same thing at the final also. Now, this one. What problems we will get in this? This are normal conventional problem is, let us suppose there is a gun. Let's suppose it's a gun. I know it is not, but it's okay. the mass of the gun is 3 kg. The mass of the bullet is, let's suppose, 1 kg. And the velocity with which the bullet fires, 10 meters per second. Then at the time of instant, when the bullet fires, what is the velocity of the gun? It is called as a recoil speed, the general term.
Okay. Oh, do I use M1 V1 is equal to M2 V2?
Because this is the total system. The gun
Right.
and the bullet, it is totally one single system. So whatever the momentum of the initial, it is same as momentum of the final. Correct?
Right. Yeah.
No. First, we calculate the initial momentum. Pi should be equals to P final. What is the initial momentum over here? Initial means like before firing the bullet. Is there any
Initial
velocity for the gun?
momentum.
Yeah.
No, right. Only for the bullet.
Only for the bullet also after firing itself. That's why initial momentum
Yeah.
is 0. Because there is no velocity for the gun, no velocity for the bullet also.
Right.
Both are at rest initially, right?
Yeah.
Now, just after firing, we have to use this consideration of what is the, when the bullet goes to the right side, the gun moves to the backwards, right?
Yeah.
So that is velocity of the gun Vg, velocity of the bullet they give. Now, what is mass of the bullet into velocity of the bullet plus mass of the gun into velocity of the gun? This is the thing, right?
Right.
So what is the mass of the bullet? It is 1 kg. Velocity?
1 kg. 10 meter per second, right?
10 meter per second plus mass of the gun 3 kg. What is the velocity?
3 kgs. 0,
We have
right?
to find out. No, we have to find out.
Oh, okay. We have to find it.
Now here you have to substitute along with the sun. We have taken the right side as positive, right? Now we know when the gun is fired, the gun will move backwards. That's why it is minus. Okay. Minus velocity of the gun. Then from here we will get what is the velocity of the gun directly. Okay.
Okay.
Here if you calculate, you will get as velocity of the gun as 10 by 3 meters per second. That is 3.3. Okay.
Okay.
No, just one question on this momentum, then we will go for this constraint motion. There is nothing but pulleys and all. Let's suppose there are two bodies over here. The mass of the first block is 1 kg. The mass of the second block is 3 kg. Okay.
Okay.
Initially, it is moving at a velocity of, let's suppose, 5 meters per second. It is at rest. This velocity of 1, velocity of 2. Okay.
Okay. So the first body was initially at rest?
No, it is initially moving at 5 meters per second. Second body also initially moving at 1 meter per second.
Okay.
Now, after collision, this 1 kg block and the same 3 kg block, they will be moving this one. If the 1 kg block is moving with 2 meters per second after collision, then what will be the velocity of this second block?
Okay. So is it the same? You apply
same thing.
The mass of each body. Okay. Mass and velocity of each body.
In anything, if they are asking the velocities and they give the initial velocities and they are asking for final, Always you have to use conservation of momentum. That's it.
Okay.
Here, why you are applying this conservation of moment? Because there are no external forces, right? All our
Right.
forces are there internal, and they didn't give friction. Also means there is frictionless. There is no external forces. Whenever there are no external forces, you can apply this law, conservation of momentum, directly.
So is it minus 2 by 3?
Minus 2 by 3.
Yeah,
Why are
so
you getting
because
minus?
it will continue to be in the same direction, right?
Yeah, it will be in the same direction itself.
Right.
So tell me the first equation that you do.
0 is equal to m1 v1 plus m2
Why
v2.
0 equals to m1 v1 plus m2 v2?
Because the final for both should be equal, right? The final velocity, like the total momentum of
The
each
total,
should be
so
equal,
P
right?
initial should be equal to P final. Okay.
Right.
What is P initial?
M1,
They have velocities, right?
yeah.
If
Okay,
if the
okay. I have to
if the
incorporate
bodies are
time.
at rest, then
Right.
velocity will be zero. Velocity will be zero. That's P initial is zero. But here the bodies are moving in the initial position also. So you have to
So,
calculate the momentum for this.
so I can't hear you.
Yeah. You have to calculate the momentum for the initial positions, right? Now they are in movement. They are not at rest. Yes. 1 second. Can you hear now? Can you hear now? Hello?
So,
Yeah. Can you hear now?
okay, yeah, I can hear you. I can hear you now. Yeah.
So here, what is the initial momentum?
So for which body?
For the initial system, initial position, this one. As I told before, the total two bodies is considered as one system, right?
Oh, okay. So M1 U1 plus M2 U2 would be the PI, right?
Yeah, that is the PI.
Okay.
So 1 into 5 plus 3 into 1, right?
One.
It is
Okay.
not equal to
Yeah.
0. You have to consider,
Yeah.
you have to see whether the bodies are in motion or in rest in the initial position. It is not always 0. You have to check.
Okay.
Now P final.
So it's 1 into 2 plus. So is it 3 meter per second?
So we will get this acceleration as
3 meter per
2
second.
meters per second. 2, I think. Calculate.
No, so 3,
8,
right?
8
Minus
minus 2, 6, 6 by 3.
3. Oh, sorry, I took it as 2. Yeah, sorry, it will be 2.
So 2 meters per second. Okay.
Okay.
Now the same problem we will see as a convention problem as this bomb types. Let us suppose there is one bomb. It is divided into two parts. Here This part mass is m, this part mass is 2m. Let's suppose after explosion,
Okay.
we know that these two pieces will move in both different directions, right?
Right.
If this is moving at 5 meters per second, then what is the velocity of this small body of mass m? With which speed it will go?
So 2.5.
2.5. Okay, you're guessing. Let's calculate. Okay, for guessing also you have to know whether, so for guessing you have to tell whether it moves with greater speed or lesser speed, right? If the mass
It'll
is
move
more,
with the
it
right.
will move with less speed. If the mass is less, it moves with greater
Oh,
speed,
it'll
right?
move greater speed. Right, right.
Hmm. So one thing is that it moves with greater speed.
Yeah,
And
okay.
just as I'm guessing, so for one thing is clear, the speed of m is greater than the speed of 2m. And there is 5
Right,
and 2 is there. So the answer can be 5 into 2, that is 10 meters per second. This is just guessing. Now we have to calculate.
right.
So let's calculate. So what is the first? Same thing, P initial it should be equal to P final, right?
Final. Yeah.
P initial should be equal to P final. So before explosion, the bomb is at rest. Both the particles M and 2M, they are at rest. So initial momentum is 0.
0.
Now, momentum of the 2M, that is 2M into 5, right? Mass into that velocity.
Yeah.
Since it is moving in opposite direction, directly will take minus here itself. Minus mass into velocity you have taken V. So here what is the velocity you will get? M gets cancelled. Velocity V as 10 meters per
10.
second. But guessing is correct. But it only works for some. Don't guess for all.
Okay.
No. So in the previous classes, we studied about the pulley, how they calculate the acceleration. And two blocks are here and all, right?
Right.
Now, for the same thing, if there is pulley, there are two pulleys.
So your voice is like really low.
So it coming at low.
Yeah, I can't hear you that well.
Yeah. Yes. So let's see now. Just tell me like if you get any low voices or any disturbances.
Yeah, so now it's fine. Now it's fine. I can hear you.
So here, what is the difference between the first diagram and the second diagram?
There's two pulleys
Okay,
in the
there are
second
two
diagram.
pulleys. Okay. Now, in the first diagram, the pulley is fixed, right? The pulley is not moving.
Right. Right.
But in second diagram, there are two pulleys, first pulley and second pulley. First pulley is fixed, okay? But second pulley is moving, right? When this block moves down, see this, when suppose A and B, when B block moves down, A block will go up. That one thing is obvious, correct?
Right.
But along with that, the pulley also move upwards because the pulley is not fixed over here. Okay.
Okay.
Here the pulley is fixed. So
Fixed.
there is no movement of the pulley. Here the pulley is not fixed. When the body B move downwards, the pulley moves upwards. Correct?
Right.
The second pulley moves upwards, and this body A also moves upwards. Now, for solving these type of questions, we have two methods. One method is directly by writing this normal formulas in the sense as equations. Let's see. So let us suppose this is the pulley, second pulley, right? If second
Right.
pulley moves upwards for a distance of x, okay,
Okay.
then by how much distance B will move downwards?
X, right.
X. Let's see. When the pulley is moving upwards, x distance, it is covering this part of x,
Right.
this part of x also. Means for this pulley to move upwards for x distance, it is taking x from left side, x from right side. Means total 2x of the same row. Correct? See here.
So I didn't understand.
Yeah. Now you have to move this pulley from here to here, right? At a distance of x.
Right.
Okay.
Yeah.
Now for moving this pulley, how much of the rope length is covered? This is the one rope length, right?
Right.
This is also the rope
Oh,
length, the
okay. So
same rope.
twice. Yeah.
This
Okay.
is also
Okay.
x, this is also x. Means it has to
Right.
cover total of 2x of the same rope, right?
Right.
Means 2x means it will come downwards with 2x, correct? When the pulley goes
Right.
up with x distance, the block B comes downward with 2x distance. Okay. Now, the
Okay.
same thing is followed for velocity also. If the pulley is moving upwards with a velocity of v, then the block B moves downwards with a velocity of 2v.
2V.
Same thing if it moving upwards with the acceleration of a, then the B move downwards with the acceleration of 2a.
2V.
Okay. So means like if this is a, this becomes a by 2. Okay.
2.
Just half of it, right?
Yeah.
Now the another way of calculating this one. So now we know once you calculate this acceleration, now we will just apply. Since we need to know only the acceleration of the block, so we are assuming this block B is moving downwards with the acceleration of 2a. You can take a also, but to avoid fractional values, just we are taking 2a. Then what the acceleration of this pulley becomes a. Correct?
Yeah.
So if the acceleration of pulley is a, then the acceleration of this block A will also be a because it is connected, right?
Right.
So if this is a, so the acceleration of this also will be a itself.
A.
Now we will write the forces for free body diagrams for B and A. So what are the forces acting for B? One is downwards.
Tension. Yeah, tension, and then mg.
Upwards tension. We have this mg. And for A,
Same tension and mg.
so this is ma into g over here, right? Now what do you want me to put here? T. So
Yeah.
the same string. So here also T, here also T,
T and
what we
then
discussed. T and T, this becomes 2T. We discussed in
Oh,
the
okay,
previous
right,
class, right?
right. Yeah, yeah,
In the pulley,
yeah.
we have this over here. Uh, If this is T and T, it total tension becomes 2T, correct?
2T.
So
Right.
here the tension is 2T, not T. Okay.
Okay. Okay.
Now just we have to write the equations. So first equation for the block B, F net, that is it is moving downward. So that is
Mhm.
mg minus T should be equal to mass of the B into acceleration. So what is the acceleration that we have
Right.
to take?
Oh, 2, right? 2A.
2A. Yeah, 2A, because we assume 2A as an acceleration for P. Okay.
Mm.
Now
Mm.
same thing for for A
Yeah.
block. So now it is moving upwards. So 2T is more,
Right.
right? That's why
Right.
2T
Yeah.
minus
Minus
MAG should be
mg.
equal to mass of the A into
Acceleration.
A or 2A.
AA.
A, because we calculated if this is 2A, this is A. That's why you have to keep. Next, just this, it's a solving. That's it. Just you have to calculate, cancel this T and T. Then we have to calculate. Okay.
Okay.
One question we will do by this method because this is a lengthy procedure. There is another method also. By using work energy theorem, we can solve it with very few steps itself. First, we will calculate it by this method. Just one thing. So let us suppose there are two other. The rope, the acceleration of this left side rope is A1. Okay.
Mm.
And the acceleration of
Okay.
right side rope is A2. And the pulley is nothing but this one is A3. Okay. Then for
Okay.
calculating this A3, let us suppose if A1 and A2 are different
Okay.
accelerations, in that case I'm taking. So this
But so,
acceleration
like,
of
it's
the,
the same string, right?
yeah, here it is the same thing, but let us suppose here also we have this another one, moving pulley. Then the acceleration of
Okay.
this is not equal to acceleration of this one.
Right.
In that case, we are talking about general cases.
Okay.
If it is same string also, but if it attached to the moving other pulley, then the acceleration may be
Right.
different. That's it. So A1, A2. So
Okay.
this A, it is the average of the both acceleration. That is A1 plus A2 by 2.
Right. 2.
Okay.
Okay. Okay.
And this acceleration you have to substitute along with the sign. Okay.
Along with the.
Along with the signs. If it is moving upwards, you have to take plus. Let us suppose it is moving up,
Oh,
A2
okay.
is moving down, plus A1 minus A2. That's it.
Okay.
You have to take along with. If let us suppose if A3 is moving downwards, then it becomes as minus A3. That's it.
Okay.
This one you have to take along with the signs.
Okay.
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 No. Let's calculate one. First, let's calculate with this normal two bodies. Here it is one pulley. Here we have some other one. Here there is a block of 5 kg. This second pulley is attached to a block of mass 2 kg. Now we have to find what is the acceleration of 5 kg block and what is the acceleration of 2 kg block. So here first you have to assume the accelerations. Okay.
So we have to assume the accelerations.
Yeah. Previous questions also you are assuming acceleration of A.
Oh, okay,
right?
as in 2A. Yeah, right.
So here we have to assume this one as, let's suppose you are assuming this one as 2A. You can assume it A also. This becomes half. That's it.
Yeah, A by 2.
A by 2. Let's suppose you are taking this as 2A. Since we know it is the same thing, if it is 2A, it becomes A. Correct?
Right.
Now we will just write the equations. Otherwise, you can calculate by using that average acceleration formula also that I told before. If this is 2A, this is also 2A, right? Right side. What is the acceleration of over here? It's not A.
Oh, it's 4A. No, wait, for that's right. So that'll be 8 plus A, right?
So here we know this acceleration is 2A, correct? Now this side, is this rope moving? It is attached to one string, one point, right? It is not moving.
Right.
Acceleration is 0.
Okay.
Now if you take the average for these two, so acceleration of the pulley is equals to 0 plus 2A, both are upwards. That's why plus 2A divided by 2. 2 gets cancelled, we will get as A.
Okay.
You can find by this method also. Since the point is fixed over here, acceleration of the rope I am talking about. Here the rope is not moving. This side rope is moving. Here the rope is not moving. That's why the acceleration is 0 over here. If the rope is moving, then you have to take that acceleration. That's it.
Okay.
And since it is moving upwards, that's why plus, 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 all are plus. Okay.
Yeah.
Now, after assuming the accelerations, just we have to calculate. Means we have to write the equations. Newton's laws of motion equation for 5 kg block. Right, for 5 kg block.
It'll be 550 minus T to give 50 into 2A, right?
5 into 2A, not 50 into 2.
Oh, sorry, 5 into 2A.
Now for 2 kg block.
2T minus 2T minus 20 to give 2 into A. 2A.
2 into A. 2. Now we have to solve it. So now how to solve this one? This
same thing, right?
So it has 10A.
Yeah.
10A. How to solve this one? Here it is T, here it is 2T.
Oh, you multiply 1 with 2, right?
Yeah, first we will multiply this one with the 2, then it becomes 2T 120. Then we will just add 2T gets cancelled. 100 minus 20, 80 should be equals to 22A.
20.
Correct?
Right.
Then we will get acceleration as 80 by 22, which is equals to same thing, 40 by 11 meters per second.
Yeah.
This is the acceleration of this A. That is nothing but acceleration of 2 kg block. Right?
Right.
Now, acceleration of 5 kg block is 2A, which is equals to 80 by 11 meters per second.
Okay.
Now we will do the same question by using work energy theorem. So what is this work energy theorem tells is work done by internal forces. Okay.
Okay.
Work done by internal forces is always equal to 0. Okay.
Okay.
This is work done by internal forces, not external.
External force.
External means where we have to apply something externally. Then they are
Right.
called external forces. So now when you see the same thing, are there any external forces over here?
Yeah, the weight, right? 2 kg and 5. Oh, force? No, there's no extra force.
External force I'm talking about. There are
Yeah,
no
no,
external
there's no.
forces.
Yeah.
There are no external forces, right?
Yeah.
Now, first just write what are the tensions on each blocks.
So I can't hear you.
What are the tensions on each blocks? What are the tensions on each block? So can you hear me now? Now can you hear me? Can you hear me now? Just a second. Now check. I can hear you. Can you hear me now? Yeah, hello?
Hello? Yes,
Yeah,
I can
hello?
hear you now.
Yeah.
Yeah, I can hear you.
So here, work done by internal forces is 0. Okay.
So your volume is very low.
So, what is the issue? Wait a second, I will change this another headset. Hello?
Yes, I can hear you now.
Yeah. So work done by internal forces is 0. Okay.
Okay.
So here the tension is the internal force for this system, right?
So your voice is breaking a lot.
What happened to today? There are a lot of issues. The two in this evening time. So just a second. So let's try this for a few minutes. Otherwise, I will just diagnose this network. So first,
So are you saying something? I can't hear anything you're saying.
no. So now can you hear it properly?
So it's breaking still. So
It's breaking. No, I just changed the network also. Let me check.
can you hear me clearly?
Yeah, I can hear you.
Okay, okay. Oh yeah, so even I can hear you now. Yeah, it's fine.
Mhm. So here we have this tension as T, correct?
Right,
So here also T, this becomes 2T, right?
right.
Now work done. So let us suppose this is moving downwards with x1. This moves up
Okay,
with some x2. We're not calculating whether it is twice or not. We move somewhat, okay?
okay.
X1 and x2. So work done by the internal forces. Here the internal force is the tension, correct? So
Right.
work done means T dot X, right? Force into the displacement, right? Dot product
Yeah.
means T1 X1 plus T2 X2 should be equal to 0. Okay.
Okay.
In the same way, if you differentiate this, you will get T1 dot, see the dot product, T1 dot V1 plus T2 dot V2 should be equal to 0. In the same way, if you differentiate this one, T1 dot A1 plus T2 dot A2 should be equal to 0.
0.
Hmm. Means if you want summation T dot A should be equal to 0, correct?
Right.
Hmm. Now, if we want displacement, we will use summation of Tx. If we want velocity, we will use summation of Tv. If we want acceleration, we will use summation of Ta. Now we need acceleration. So let us suppose your down is A1, up is A2. Okay.
Okay.
Now we will use the same summation of T dot product. See here, dot A equals to 0. So first T1, that is T itself upwards, right?
Right.
Acceleration is A1. It is dot product, right? Means cos theta.
Right.
The angle is 180 degree, so you will get -1, correct?
Right.
T dot
Okay.
A means TA cos theta, correct?
Right.
So TA cos of 180, because both are in opposite direction, you will get as -1.
Right.
Plus, what is the tension for this 2 kg block? 2T upwards, right?
So your voice has started breaking again, so
Mm, I think today there are a lot of issues. I don't know. Just Actually, the network is disconnecting for every 10 to 15 minutes. Don't know why. I contact the service provider. I will complain regarding this. So no.
Yes, I
So
can
here,
hear you properly.
so here it is T A cos theta, correct?
Yeah,
So T A1 cos theta is cos of 180, that is -1.
-1.
Now plus. Now for this 2 kg block, tension is upwards 2T,
Hmm.
correct?
Yeah,
So
yeah.
2T into acceleration is A2
A2.
into both are in same direction, means theta is 0. Angle between 2T and A2,
Right.
both are in same direction. So theta 0, right?
Yes, both are in same direction. Right.
So
Yeah,
that
so
is
it's
1,
1. Yeah.
should be equal to 0.
Oh, okay.
Now, if you solve this, we will get as T gets cancelled. A1 equals to 2A2, correct? A1 equals to 2A2.
Hmm.
So, same thing. Let's suppose if A1 is A, if A2 is A, then what is this A1?
So which one is A?
A2.
A2. Okay. If
A2 is
A2,
A,
then A1 will be A by 2, right?
A1 is 2A, correct?
Yeah,
2A2.
A1 is 2A2. Yeah.
A2, we are assuming it as A.
Okay.
Then A1 becomes 2 into A2, that is 2 into A. 2A, right? See this.
Oh, yeah, yeah, yeah. No, I wrote the values wrong. Yeah, yeah, sorry. Yeah, that's right.
Okay. So whether you can do this method or just assuming A and 2A. But assuming that A and 2A, it is useful only for 2 pulleys. If they give more than 2, then it becomes difficult.
We have to use.
Okay.
Okay.
If
Okay.
you use this method, it is applicable for all the questions. And you can apply it
Okay.
very easily also.
Okay.
Now, just one simple question on this. This is a frictionless surface of mass 2 kg. It is attached to it. There are 2 pulleys. One pulley is fixed, another pulley is moving. What is the acceleration of 2 kg block?
Oh, T.
Use this work.
Oh, okay. T.
So this is, so we're just assuming A2 and A1. So if this is T, here also will be T, here also will be T. So the tension on the block is 2T, right?
2T. Yeah.
Now we will write the normal equations. Normal means that work equations.
Right.
Hmm. So here we have write it for T.
So it'll be minus T A1 plus 2 T into A2 is equal to 0, right?
Hmm. So the equation is correct.
Oh, okay.
Signs
Wait.
also just you have
Oh,
interchange.
matters. Right. Oh.
It is
Oh, so you
just
took
summation
A1
of
as that
E
one.
dot. Oh, you can take anything, no problem. I will take A1, this
Yeah.
one, A2. Oh,
Okay.
okay. Hmm. So just to told minus T A1 plus 2T A2. Right?
2T A2 is equal to
It's
0.
equal to 0. So then we will get A1 as 2A2. Correct?
Right. Yeah.
Assuming that A2 as A. So this as A. This becomes 2A. Correct?
Right.
Now write the NLM equations. Newton's laws of motion equation for 1 kg block.
So what did you say?
NLM. Newton's laws of motions equations
All of
for
them?
this 1 kg. Now we have two bodies, right? 1 kg and 2 kg. For 1
Right.
kg, we have downwards mg. This one is used
Hmm.
for finding the relation between accelerations.
Okay. Okay.
So for 1 kg, we have this one. It is moving downwards. So that is 10 minus t equals to 2a. Correct?
Yeah. Right.
Now for the 2 kg block. Tell the equation for 2 kg block.
2T minus 20 is equal to 2. Yeah, 2A.
2t minus
Sorry,
20
A2 into
equals
A
to
by 2. So A. So what?
into 1. No, this is correct. This is 2 is mass of the
Okay.
body. A is the
Right.
acceleration. Here
Hmm.
1 is the mass of the body. 2a is the acceleration. Then we will
Right.
just multiply and we will calculate. Understood this one?
Yeah.
No.
So for the second equation, right, for 2G, I mean 2 kg, it'll be 2T minus 20 is equal to A, right?
2t minus 20 equals to mass of the body into acceleration. Mass is 2 kg.
Right.
That's why I have written 2a. And acceleration
Yeah.
is a itself. That's why
So
2a.
won't it be
Not
A by 2?
why a by 2. Here you have taken 2a, right?
Yeah.
If it is a,
Okay. No,
then
so
it
it'll
becomes
still
a by
be A by
2.
2, right? Yeah.
See here, if it is a, then it is a by 2.
Oh,
If it
okay,
is 2a,
okay.
then
Yeah,
it is
right.
a. Just
This will be
because
right,
if
right.
there are this a by 2 in this, then it will be difficult for calculations. That's why what we are doing, we're directly taking it as 2a and a for avoiding the fractions. Okay.
Okay.
Just for
Okay.
avoiding fractions, we are taking 2a and a. Otherwise, you can take a and a by 2. Both are the same.
Hmm.
Okay.
Okay.
There are two blocks on a frictionless surface. Block 1 and block 2. Suppose there is a pulley over there. So here it is attached over here. Here also one pulley is there. This is the configuration. Now the two pulleys are also moving. Only this is the attached one. Let's suppose
So
it
is
is
that also
moving.
pulley?
Yeah, this is also a pulley.
No, the one
Here,
beneath
no,
that?
this is just a point. That's it. It is just as
Okay,
a
okay.
holding point.
Okay.
Let us
So
suppose
aren't
this.
both? Like fixed pulleys?
With respect to second one, this is fixed. With respect to first one, this is fixed. But when you're standing on the ground, when you see this,
Right,
both pulleys will be moving, right?
right.
Like let's suppose if this second block is moving with the acceleration of 10 meters per second square. If it is moving
Okay.
this side, then what is this acceleration of this first block?
I don't know how to like calculate it. So.
Here also the same, you have to use this work theorem gives the relation between the accelerations, correct?
Right. Yeah.
Here they gave acceleration of first body, asking the acceleration of second body. That's it.
Second body. Okay.
Because of the relation between the two accelerations. So let's see how to do this one. In previously what we did, so T dot A equals to 0, correct?
Right.
So first write the tensions in each of them. Let us suppose here the tension is T. You can start from anywhere. Here I am starting from here. Let us suppose this is T. Here also it's T. Same thing. Here also it's T. Correct?
Right.
So if this T and T, this becomes 2T. Correct?
2T. Yeah.
Here also T and T. So here also it is 2T.
Yeah. 2T.
Now just you have to apply this one. Tension on the block multiplied by acceleration of the block. That's it. So first,
Okay.
tension on the first block into acceleration of the first block plus tension on second block, dot product of acceleration of second block should be equal to 0. Correct?
Right.
What is the total tension on the first block?
2T, right?
What about this?
2T plus T, right? 3T.
Total there
3T.
are 3T. So 3T.
Oh.
Acceleration we don't know.
Hmm.
In which direction? We don't know. You can assume it any direction. If it coming as positive, then the assumed direction is correct. If it is coming
Correct.
negative, the assumed direction is just reverse of what we assumed. Okay.
Right. Okay.
Let's suppose you are assuming in the right side direction. Then this tension and acceleration both are in same direction. Means theta is 0, right?
Right.
So that is cos 1. No negative sign will come. So plus the other side like into 1. That is cos 0 for that one.
Hmm.
Now what is T2?
2T
2T
into 10.
dot word into 10. See the direction. 2T is in left side, acceleration in right side.
Right.
Theta
Oh,
is
so negative
180.
sign.
Negative
Yeah.
sign will come. That is
Oh.
minus 10. Otherwise, just keep 10 as it is. Right, minus
Yeah.
1 because cos theta equals to 0.
Yeah.
We can cancel it T and T directly because it is 0, right? Equal to 0. Directly we got 3A1 minus 20 equal to 0. We got A1 directly.
Yeah.
20 by
20 by 3.
That's it. What you have to do is first you have to find what are the accelerations. Okay. You have to see whether they gave accelerations or not. They gave acceleration, asking the second acceleration. Okay. We assumed one direction. After that, we are just writing the forces, that is writing the tensions in each of them. Correct?
Right.
Then just after writing this equation, you can solve. You will get the answer.
Okay.
Understand this one because the next question you have to do by yourself. If you have any doubt, just ask it.
Okay.
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 See here. And you have to understand why the pulleys are moving. With respect to this block, this pulley is fixed. But when we are observing it with respect to ground, the both pulleys will be moving itself. Right?
Right.
That's all. Understood this one, right?
Yeah.
Now, this question you have to do. Frictionless surface. Why maximum case it is frictionless surface itself? Suppose there is a car or a car A. There is a pulley. It is attached to a pulley, and here we have another. Don't get confused by the diagrams. Diagrams are confusing. The concept is simple. Just you have to apply. Here there is one car. A car B. Okay. Now this angle 37 degrees. If the car A is moving left side with a velocity of 8 meters per second, then what is the velocity of car B? So just first thing is, if the car A is moving left side, car B will also move towards left, right? VB, right?
Yeah.
Now just you have to use this work theorem. Work theorem is not only for accelerations. It is for displacement, it is for
Right.
velocity, it is for acceleration. Okay, now we have assumed all the directions. Now write the forces. That is the internal forces. Means tension.
Shall be T into 8
Okay. T.
plus.
First, tell me the directions. T in this side, this direction, right?
Right.
Right side, because it is always away from the
Okay, so
body.
it will be negative. Right, right.
You have to take tension always away from the body. Here
Right.
also tension on B. It is like this. Same string, so tension is same and away from the body. That's it. Now tell the equation.
Will it be negative 8T?
Negative 80 plus. Whether it's plus
Plus
or minus,
3
we will
by
see that. 3 by
plus 5. A2 it should be equal to 0.
3 by 5.
A2
A2
should be
equal
equal
to
to 0.
0.
Right.
How to eliminate T? Here it is T by A2 you got. It is V2. We are calculating velocities. Okay. It is T
Oh,
dot
sorry.
V, right?
Yeah, well.
There is tension in this.
Oh, sorry. Yeah, T into
T
3 by
into
5 V2, right? 3
why
by
3
5
by
V2.
5 V2?
So cos, right?
Yeah, what is cos 37, correct?
Yeah, yeah.
Cos 37.
So it's 3 by 5.
This one. This is the triangle. 37 degree. Opposite to 37 is the lesser angle, lesser value. So this is 4, this is 5.
4 by 5.
Okay.
Okay.
So it is 4 by 5. V2 equals to 0.
0.
If you solve this, you will get this as V2. As directly, how much you got? 10 meters per second. Calculate.
10 meter
Yeah,
per
10
second.
meters per second. That's it.
Okay.
Okay. Now, one question. For this question, first you have to guess. Okay, I will give the options. Guess the option, then we
Okay.
will do the question. You will do a normal method. There are two pulleys. Two pulleys are attached to a block. If these two blocks are moving down with a velocity of
Okay.
u and u, okay,
You and?
u, both are u.
Okay, okay, both are you.
So, this is theta. Okay, this is also theta, the same angle. Yeah.
Okay.
Then what will be the velocity of A? It is u meters per second. U meters per second. First block, second block. Let's see the options. First, as 2u cos theta. Second, u cos theta. C. U by 2 cos theta. D. U by cos theta. So first, if you guess what will be the answer. Otherwise, they can do directly for proceeding instead of guessing. How to calculate this? U,
So is it,
yeah, tell me.
yeah, is it A 2u cos theta?
A 2u cos theta. Okay, let's see whether
Okay.
it is correct or wrong. So this is u. So this will also moving with u, correct?
Right.
Otherwise, we'll take the tensions, no problem. Because we studied by using tensions, so we'll take tensions. Here if the tension is T, here
Right.
also T,
Hmm.
here also T. So here also, because the same
T.
string,
String.
T, 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 okay?
Right.
All are T's. Now we assumed, okay, just assume that one direction for A. Okay, it will move upwards with the velocity V. We have to calculate what is V. That's it, right?
Right.
So it moves upwards, right? When first body and second body move downwards, the A block will move
Downwards and
upwards.
move. Right.
So that's why I assume that. Now just we will calculate. So here, first for first block, T outwards, U downwards, right?
Right.
So it becomes minus TU for first block. T upwards, U downwards. Both are in opposite direction, correct?
Right.
That's why minus.
Okay.
Otherwise, I write in this form itself. T U into minus 1, correct?
Right.
Plus, right for the second block, T U into minus 1, same itself.
Hmm.
Plus
TU.
Now for this one, there are two tensions, but it is moving along vertical direction, right?
Right.
So this is the velocity upwards, v. So v, so t, v, first due to this one. Angle between this is cos theta, right?
Right.
TV cos theta plus, again due to this t, again we will get TV cos theta, correct?
Right.
So one due to this one due to this one. TV cos theta should be equal to 0.
So shouldn't one be sine?
Why sine? This is T
Isn't it
dot
like a
V,
right?
right?
Oh, okay. Yeah,
TV
yeah,
cos
yeah.
theta.
Right.
We are taking the dot
Yeah.
products. We are not taking
Yeah, yeah.
components.
Right. Okay.
Like if you take components also, it is T cos theta itself, right? Because both are adjacent to T.
Hmm.
You will get
Yeah,
T
yeah.
cos theta and T cos theta itself.
Yes.
Okay, TV cos theta plus TV cos theta equal to 0. That's it. Solution is done. T gets cancelled. So what you will get? Minus 2u plus 2v cos theta, right?
Yeah.
Equal to 0. 2 gets cancelled. V equals to u by cos theta. Right? Calculation is correct.
Right. Yeah.
So the answer is D.
D.
Okay.
Okay.
In general, what we will think is since it is u. So upwards we will get as u cos theta. Upwards we will get as u cos theta by this. So we will add both two. We will write 2u cos theta. But this is not the actual case. It works. Okay.
Okay.
You have to calculate it total. That's why we should not guess maximum of the times.
Okay.
Mainly for these type of problems.
Hmm.
That's it. I will send some 2 to 3 questions on this, and you have to do by per theorem itself. Okay.
Okay, sir.
Okay, I will send the 2 questions, 3 to 4 questions. There may be some 3 to 4 pulleys also, but you have to use only one method. Just assume the direction of the accelerations and tensions. Then write the power this work equation.
Okay.
Okay, that's it. I think today there were more of disturbances regarding this net and all. I will
Yeah,
just
so
check that.
my even
Yeah.
my network was really bad quality today.
Sometimes it happens. I will just try. It works fine, but let's see. Okay then.
Okay, sir. Thank you.
Yeah. Okay. Yeah.
Bye, sir.